Today we want to learn how to simplify expressions when we have two rational expressions, either adding or subtracting. So looking at these, the first thing that we want to be able to do is figure out how to make the denominators to be the same. And when I mean the same, I mean to have the same factors in each one of the denominators. So looking at our first fraction here, we already have some common features. We've got an x in both of the denominators, but the numbers aren't the same, and we don't have the same amount of x's in each one of the denominators. So in order to get them the same, what I'm going to have to do is multiply each of these denominators or each of these fractions by the missing factors. So this first fraction is missing a factor of 3, and it's also missing one of the x's. So I need to multiply both numerator and denominator by each one of those missing factors. The second fraction has both of the x's, but it is missing a factor of 5. So I'm going to go ahead and multiply by that factor of 5. So now each one of those denominators has a factor of 3, a factor of 5, and two factors of x. So then if I actually multiply those out, 3x and 6y multiplied together in the numerator is 18xy. In the denominator, that's going to multiply out to 15x squared. And then I can go ahead and add that to my next fraction. Multiplying the 4x and the 5 in the numerator will give us a 20x. And the denominator again will give us a 15x squared. So then if I add these together, the one thing that will remain in common is the denominator. So that stays as 15x squared. If I add the numerators, I don't have any like terms because I've got an xy in this first term, I've got an x from the second term. Those are different, but I can consolidate this down into a single fraction. So this can become 18xy, and then plus the second piece is 20x, and that would be my combined fraction for those first two expressions. So we found a common denominator by ensuring that we had the exact same factors in each one of those denominators. Once we had those, we could go ahead and combine any like terms up in the numerator and leave the denominator as it is. Now, if we look at the second one, we can do the same thing in figuring out what are our common factors already, what needs to be introduced so that they have all the common factors in the denominator. So the numbers aren't the same, but I can introduce a factor of 2 to the second fraction so that the 2 times the 3 would get us up to the 6. We have 3 factors of x in the first fraction. We only have 1 factor of x in the denominator of the second fraction. So I'm also going to multiply by an x squared so that I have 3 total factors of x in that second fraction. But then this first fraction doesn't have any y's in the denominator, so I need to multiply by that y squared in both the numerator and denominator so that I have that in common as well. So then multiplying by what we have gives us a y cubed over, if I multiply the denominator, 6x to the third, y to the second. And then I need to add to that my second fraction. If I multiply out that numerator, that becomes 10x squared. And the denominator ends up being the same, 6x to the third, y to the second that we found in the first fraction. So then if I combine these together, my common denominator stays as 6x to the third, y to the second. That doesn't change. And since I have different variables or exponents on my numerators, I'm just going to combine this into a single fraction as y to the third plus the second numerator of 10x squared. And that would be my combined fraction.